So in today's video, we are going to talk about data transformation in data engineering lifecycle, and we'll try to, of course, walk through each and everything step by step, and we'll try to understand what data transformation actually means and where it actually happens, and why the business logic drives most of the data transformation, and how it is actually used differently for data analytics and machine learning. And also we'll of course discuss about what are some of the key things that you need to think about or that you need to consider, like before building any kind of data transformation pipelines. Okay. And that is irrespective of whether you are working with the batch ingestion or streaming ingestion or maybe hybrid workloads as well. So yeah, and to be honest, actually I would say, even though like every data engineer kind of has to do some kind of transformations for sure. Okay, everyone has to write some kind of transformation code, but data transformation is also, I would say, one of the most misunderstood topics in data engineering. Okay, and why I'm saying it is one of the misunderstood topics in data engineering is many people, especially like junior data engineers or people who are just starting in their data engineering journey, or even some of the mid-level data engineers as well, right? Normally, normally of course, what they think is, so everyone of course would have heard about the terms like ELT and ETL. So if you don't know what ETL or ELT stands for, E for extract. Okay, so E for extract, T for transform, and L for load. Okay, so 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 why I'm saying it is one of the most misunderstood topics in data engineering is, I'm sure like many of the people would have heard the terms ETL and ELT, which is extract, transform, load, or extract, load, and transform. But and whenever you ask some people what actually T stands for in ELT or ETL, they will say it's mainly, T is mainly about writing the PySpark code or SQL code or Python code, or maybe like maybe they will go one step ahead and say, they will say something like DBT handles a transformation, or we are handling transformations in PySpark and everything. But but when you ask why are you actually transforming these data, and what kind of a business rule, or what kind of business rules actually BRMs are being encoded into the transformations on top of the data, then most people can't answer that. Okay, so people don't understand why are we actually transforming this data, and what kind of business rule is being encoded into it, and what kind of business value it is getting. Okay, it is giving. So without understanding the business behind, or business rules behind the transformations, unfortunately, like most people, what they think is transformations is about like writing PySpark code or Python code or SQL code. Okay, and I would say, that's not fully correct understanding of the transformation. So what we do now is, let's try to remove all the buzzwords and talk about this the way, like for example, senior engineers actually do in real life projects. Okay, so let's try to understand what transformation or what data transformation actually mean. Okay, so basically, transformation means that it's just changing raw data into something useful. Okay, so it's just about changing raw data into something useful. And if you have watched some of my previous videos where I have explained what data engineering is actually about, I have told that data engineering is all about turning that raw data into useful data. Okay, and useful for business people. Okay, useful for business people in order to make decisions which will drive the performance of the company, like by increasing the revenue, or by improving the profits, or like, and how they do that is like they will do that by optimizing the performance of the products or processes, and stuff like that, or also maybe they can improve the sales or all that stuff. Okay, so I'm saying data engineering is all about converting that raw data to useful data for the business people, right? So in order for them to like make decisions that can improve the performance of company, okay, overall. Um, so one thing here we need to remember is, if you have also previously saw my video about data engineering lifecycle. So in the video I have mentioned about there will be data sources where data will be getting generated, and then so inside your data platform, so you will probably do all the different kind of steps. Step one is like ingestion, and then step two is transformation. Okay, not in the same order. And then other step is serve, and then there will be storage underneath, okay, which acts as like a common thing between each and every layer. Okay, and then at the end, of course, here you can have your analytics jobs or reports or dashboards or machine learning models and all that stuff. Okay, and yeah, so in ingestion we'll normally collect the data, and then we'll store it into storage, and then and then uh, and then in transformation what we do is we read the raw data that we ingested from sources, and then in transformation we actually apply business rules, and then convert that raw data to meaningful data. Okay, and in the final step we'll serve that data. Okay, so now from my words you might have kind of understood that why transformation is actually needed, right? We need transformation because you can't get actually the value out of the raw data itself, right? So raw data is raw data. Okay, so basically raw data is byproduct of the source systems, right? So it can be like logs, or it can be raw data can be like logs or transactions or events or metrics, and by raw data itself it doesn't give like it doesn't give the business people any kind of insights. Okay, so transformation is actually the place. Transformation is actually the place where data actually becomes valuable. Okay, so that's why we do transformation. And then what we are saying about like what data transformation actually means is, so basically transformation is all about converting that raw data to something useful. Okay, of course, if we have to convert that raw data to something useful, first we have to have data, right? And then that we will do by ingestion. And then yeah, and then transformation is the place where you'll read the raw data and then do some kind of business logic or apply some business rules into it, and then transform the data in such a way that it creates business meaning. It will have business meaning. Okay, so basically in ingestion you're just collecting the data. So without transformation the data basically doesn't give any business insight or doesn't hold any business meaning to it in most instances, especially for analytics or reporting or machine learning purposes. Okay, that's why we need to do transformation. Okay, for example, if we have to see some kind of small or maybe a little bit vague example, but I'll try to show some examples. So let's say we have this data right over here. Okay, let's say we have this data, right? So here what you see is basically, let's say imagine there is some e-commerce company like Amazon or Flipkart or something like that. So let's say that there is Amazon e-commerce company. Basically in Amazon what will be happening is orders will be happening constantly, right? So if you have to look at the orders data, then it might look something like this. Okay, so it might look something like this, and here you can see order ID. Okay, and here you can see price, quantity, and then timestamp, and then currency. But then if you actually look at this closely, here price is price should be like numeric, right? It should be like integer or decimal or something like that. But here you can see that it's enclosed in double quotes. So it is a string here in raw data. Okay, and in quantity is also actually of type string. Okay, so and here if you see timestamp, it is also of type string. Okay, and currency string, that's fine. Okay, so but one of the transformation that we can do here is one of the simple transformation that we can do here is for example, let's say you know one of the simple transformation step is basically standardizing this data. Okay, so this is also one of the pretty most common step, which is standardizing the data. So what we do is if the columns like price or quantity, if they are in string format, then we basically can't do any kind of calculations on it, right? It's a little bit hard to do. So that's why what we'll try to do now is we'll try to cast it to decimal or integer. So here if you look, we are casting price to, we are writing a simple select, and again I'm saying, so this is a sample step. Okay, but you can write your transformation logic in Python or PySpark or whatever. Okay, it doesn't matter. Okay, so here but we are writing a simple transformation step, which is standardizing step. What we are doing here is we are converting price to decimal and quantity to quantity to integer. Okay, because why we are converting price to decimal is price can be also in decimals, right? So price should not be like, it should not be like, it should not be like proper number. It should be like 30 rupee, $30 and 50 cents, or something like that as well, right? So that's why we are casting it as decimal. But for quantity, okay, we are keeping it as integer. And then so in transformation step you can also of course do calculations. Like for example, if you want to calculate total amount, okay, then it is price multiplied by quantity, right? So for example, if you went to supermarket and if you buy 10 bananas, and then let's say each banana price is like 2 rupees, then what you'll do is 10 bananas, and then each banana price is 2 rupees, right? So then if you want to calculate the price of 10 bananas, then what you'll do, 10 into 2, which is equals to 20. So same calculation goes here. If you want to calculate total amount, okay, then it is price multiplied by quantity. And then of course here in the raw data, if you see, this is the raw data. Okay, and then here we are standardizing it. This is the sample SQL query to standardize the data. So here also the timestamp is in string format, but then here if you look at it, we are converting it into we are converting it to timestamp format. Okay, and then of course we are also renaming the column as order timestamp. Okay, so that's also important. So so in so some of the transformations can be, you can do standardizing. Okay, or you can deduplicate the data, or you can apply business rules. Okay, and you can do much more basically. Okay, you can basically rename columns in a way that it makes business it makes sense to the business people. Okay, so you can do so many steps in transformations as part of the transformations. So now if you look at the result of this query, right? Now if you look at the result of this query, now it is actually, you can say that it is useful. Okay, but whereas if you look at the raw data, this is actually might be fine for storage, but not really useful for analytics, right? So that's why we'll do transformations. Okay, we'll do transformations so that it will be it will be useful for business people. Okay, and it will give business people some business benefits so that they can make decisions by looking at that data. Okay, so that's the whole objective. And now if you are looking at the output of this data, if you kind of understand the output of that data, now this will be useful because it has correct types. Okay, because we are casting the input columns, and of course it will have consistent timestamp and derived values. Derived values or derived columns is like where you will be calculating the result of a column based on different columns, okay, available. So here we are calculating, or we are deriving new column called total amount, and we are doing that by multiplying price, okay, and quantity, right? So exactly, so this is called derived column because it is getting derived from the existing two columns, right? So so in transformation, so now this is useful, okay, the result of this will be useful, okay, the result of this transformation will be useful because we are using like correct types, and we are getting like consistent timestamps and derived values, okay. So this is exactly heart of transformation, even though it is like a little bit simple and vague example, but this is the heart of transformation. It's about like all that refinement and enrichment, so that raw data will be useful to the business people, okay. So so actually now if we move on to the next section, if we move on to the next section, that is where transformation happens in real architecture, okay. So so I'm sure many of the people might have had this doubt, right? So, and what is the doubt? The doubt being where transformation actually happens. So whether it happens at the source, or whether it happens once it enters the data platform, like in ingestion phase, or whether we should have a separate step for a transformation, or where should we actually do the transformation, okay. It's all about that, okay. So where transformation happens, so let's talk about this one. So to be honest, actually, I would say transformation can happen in multiple stages, okay. Transformation can actually happen in multiple stages, and the placement of where your transformation should happen actually depends on the architecture and the business requirements. So let's try to understand what do I mean by it depends on architecture and business requirements. So what we are saying is, we are saying transformation can happen in multiple stages in reality, right? So maybe let's talk about what are some of the stages like where transformation can happen. So let's say maybe at source it can happen, transformation can happen. Maybe during ingestion, during this phase it can happen, right? Or we'll also normally have a separate transformation stage, and then we'll be writing, and the result of the transformation stage, whatever the data will be coming out of the transformation stage, we'll be writing it back to warehouse or lake house or any kind of database. So I will probably say something like warehouse or lake house or any kind of database or any kind of storage basically, okay. And then it can, if you are following, like if you are using like stream ingestion pattern, it can also happen in stream as well, okay. And then let's talk about examples actually. So now we know that it can happen um, in all these phases, right? But like what are the examples of them actually, and we should also talk about like why it happens there. So if we talk about the first one, which is transformation can happen at source, then for this, some of the example would be like maybe let's say your application itself, okay. If you are if you have this application server on database or operational database pattern or architecture, then it kind of looks something like this. So for example, uh, sorry, I have to drop boxes. So you'll have some kind of application server 1 and server 2 and server 3 or something like that, okay. And then there will be some operational database here, okay. So yeah, so there will be some operational database here. So what will be happening is, right, so your application servers itself, okay, your application can itself like add some kind of columns, like maybe, I don't know, event timestamp or geographical location or something like that, okay. So they can add event timestamp or geographical location, or any, they can enrich the raw data with any more information that can be useful for downstream systems, okay. And then why we should do it here, and what are the advantage of actually doing the transformation at the source itself, okay. So I think it's pretty obvious. So maybe actually, if you do transformation at the source, then it kind of reduces the downstream work, or reduces the load on the downstream systems, and improve consistency actually, because um, it is source, right, and obviously it is source, and they know what they're doing, hopefully. And then so if so it is about like shifting the transformation left here. So when we do the transformation at the source, then most of the time you don't have to do the same transformation again in the data platform, right? So it is kind of reducing, downstream work, okay. And then of course, I think also it improves consistency if they do it, because they can make the data consistent at the source itself, whatever the data points are available, and then push it, okay, instead of us trying to do everything. But yeah, there are of course like trade-offs to everything. Yeah. But in this video we are not going to talk about the trade-offs, and which is best, or which can suit better your needs. But let's try to understand what is what, and then we'll of course make a more in-depth video talking about like each and everything. And then now let's move on to the transformation where it can happen during ingestion, okay. So here, for example, it can add some housekeeping columns, and you normally add some kind of housekeeping columns, okay, to help with some kind of versioning, or versioning, not or actually versioning and lineage, okay. And then if you talk about like warehouse or lakehouse or database storage, so where normally there will be separate different transformation step, or transformation layer, where you will be doing the transformations separately. For example, uh, where you might be doing transformations using dbt, or PySpark, okay, or or maybe some other technologies as well, okay. So where here you might use dbt or PySpark or other stuff, or just normal plain SQL, okay, and handle business rules and modeling, okay. And here, since if it is like warehouse, then it's probably like most common place for analytics friendly data, right? And yeah, here again we will most of the time go with, especially for server layer, many people go with warehouse as their storage artifact, because it's good for OLAP, okay, online analytical processing. So yeah, and then it can also, transformation can also happen at like in a stream, okay. So yeah, you can actually again do Spark transformations here, again maybe Kafka, or not literally in Kafka, but yeah, there will be message brokers, and then yeah, Flink as well. And here, this maybe you might end up doing like in-stream transformations, like and they will be used when business needs real-time behavior, or they want to see some kind of real-time business meaningful data instantly, then you'll do it, okay. So here, whenever business needs real-time behavior, okay, then you'll do kind of in-stream transformations, okay. So real time, behavior needed by business. And one more most important thing you need to understand. So these cases, whatever we are talking about, they're not like they are not like proper golden rules. Of course, it depends on your architecture, and it depends on your source, and it depends on the scenario you are in. It depends on your business processes and requirements and all the constraints you will be encountering real world projects. Okay, and for instance. If we had to talk about more examples, like for instance, like platforms like maybe DoorDash or Uber or maybe Zomato or Swiggy, they don't wait for bad jobs to like transform order status, right? So these transformation happens as events flow through the stream. Okay, so this is again also one of the most important example, or like most common example for in-stream transformations, right? So because if you try to do the if you try to do the transformations as bad jobs, where real-time behavior is kind of expected as part of the product experience or product user experience, then that kind of breaks the whole flow, okay, and whole user experience, and we don't want that to happen. And that's why in those cases we'll do transformations in stream. Okay, yeah. Yeah, and also, but yeah, that's for example, DoorDash or Uber Eats or Swiggy or Zomato. Yeah, that's a classic example for, or also Uber Ride or Ola in general. They are a classic example for doing in-stream transformation. But something like maybe month-end financial reconciliation or some kind of a forecasting, or maybe some dashboards, let's say, that don't needs urgency. So there you will probably do batch transformations, and they will be perfectly fine. Okay, and I hope that makes sense. Now moving on to the next section, which is let's try to understand how and why business logic drives transformation. Yeah, business logic drives data transformation. Okay, now what do I mean by business logic drives transformation? Okay, let's question, actually, let's try to understand why do we actually write any kind of develop any kind of transformation logic at all in the first place. Okay, why do you write PySpark code, or why do you write SQL code, or why do you write Python code using pandas, or any kind of Python libraries, or anything basically? Why do you write as a data engineer, why do you write data transformation code at all? Okay, so to be honest, this is exactly the part I was talking about, like where beginners, beginner engineers kind of misunderstood. Because and I don't, it's not like I'm ranting or I'm blaming them, because we don't have, because when I started also as a data engineer, no one really told me to think in these terms. And it took like real world experience for me, working in projects, and and everything. Okay, and so after so many failures later, and so I have learned some things. So similarly, okay, and also we have talked one of the most important reason for not knowing what drives which and everything, is because like we don't have proper curriculum for anything related to data stuff, or especially data engineering in universities. You can have something, people, universities have some curriculum about data science and analytics, but they touch up very little about the data engineering, right? So also that's one of the reason. Yeah, yeah, and as I was saying, this is the part where beginner engineers misunderstand the most. And people think it's about writing the technical code, or developing some kind of logic. But transformation is not just technical, it's actually business logic which is encoded into the data. Okay, let's say you have some if you had to talk in examples, let's say you have a CFO in your company, like a company like chief financial officer, or chief operational officer, or operating officer, or chief data analytics officer, or chief data officer or any officer, okay, or maybe just your manager, okay. So they might ask, okay, they might ask, let's say, some question like, what was the revenue for some particular product for product X in the last quarter? Okay. They might ask some question like, what was the revenue, okay, in the last quarter? Now, now, how can you possibly can answer this question, right? So, if you want to answer this question, you basically need to see, probably maybe some sales data or some orders data or something, and then yeah, and then you kind of have to write some, if it is in Excel, you kind of have to use some formulas and then calculate, right? And if it is some SQL, you have to write some SQL query and then calculate. And then obviously whatever the number it gives, and then you have to tell that to your manager or whoever is asking this question, okay, to you. So yeah, so now if they ask you like, what was the revenue in the last quarter, it's like, so this question or this metric is one of the driver, okay, is one of the driver for you to develop some kind of transformation logic, right? So then what you might do is, if you already have some kind of tables, then you might probably do maybe something like sum of price, okay, into quantity, and then if you do price into quantity, then you will get total amount. But then if you do sum of total amount, then you will basically get the, yeah, revenue actually. But whenever some business people ask you like, what was the revenue in the last quarter, um, they usually mean they can usually mean different things. They might be saying like, in their minds, so they might be saying something like, what was the revenue in the last quarter, maybe after taxes or after refunds or after currency conversion or after promotions, and or maybe after applying accounting rules like accruals or revenue recognition and all that stuff, okay. They might be asking with something in mind like, okay, if you deduct all these things from total amount or sum of total amount you got, then what's the revenue? But how could you possibly know this as a developer? So that's why you have to, whenever someone asks you any request, whenever someone asks you to extract some data or extract some figures from the data, you basically need to ask them a lot of questions in general. It should be back and forth, okay. So you should basically need to ask a lot of questions in order to gather requirements in detailed, okay. That's most important thing. And then based on the requirements, okay, so what you'll do is you'll do Q&A. So first there will be some kind of question coming to you, okay, and then what you'll do is you will be doing Q&A with the requester, whoever requested with whoever asked you to provide this information. You'll do some kind of question and answer stuff back and forth. And then once you got enough information, okay, that you will use as a requirements, okay, for developing the any kind of transformation logic. And of course that can be in SQL or Python or PySpark or anything, okay. And then of course how will you know that whatever the logic you developed or whatever the transform you are performing is correct or not? How will you know that? Is, of course, you will do testing from your side, but then you will also check with the requester whether it is correct or not. And then if they say, if it is correct, if he or she says it is correct, then that's good. or if it is like if it looks like some kind of outlier, or if you need to exclude more data, then they will probably give you more inputs on the requirements, and then you kind of need to incorporate them into the transformation, and then you will show them the result again, and then they will give you the feedback and all the stuff like that. Okay, and normally that's how it happens. So again, one more thing I'm saying, so transformation pipeline is not just about formatting or standardizing or consistent the definitions. It's mainly about like codifying the definitions, or codifying the business rules, or encoding the business rules. Okay, so whenever they ask you, like whenever business people ask you what was the revenue in the last quarter, they usually don't mean it's just like sum of price into quantity. They usually means, so what they usually mean is something like this. If we have to see it in SQL form, then they mean something like this. Okay, so if you are just calculating price multiplied by quantity, then it's gross revenue. Okay, it's gross revenue. But if you have to calculate net revenue, then you kind of have to, you know, multiply price and quantity, and then subtract it with discount amount or any refund amount, and then taxes, and then you will get the net revenue. Okay, so most of the time this is what like business people will be expecting. And here, if you observe closely, here we are actually joining two things. One is orders, and then one more is tax taxes. Okay, so yeah, so all this kind of joining, which is also integrating or enriching, and then some kind of calculations and derived columns, will be doing in the transformation phase as well. So yeah, so my main point is being, what I want to say is actually business logic drives the transformation. Okay, business logic is the one that drives data transformation. And how will you know what's the business logic? Of course, you need to have pretty good understanding of your department or company. Okay, and what's the company's or department's business is about, and then even if it is about the department, and you need to know how does it fit in the entire organization. And of course, um, people don't expect you to know, as a tech guy, people don't expect you to know all the business, but you need to know some of it at least. And then of course, you can always reach out to your business people. Okay, and then understand more about the business from them, and then use their inputs as a requirement, for your data transformation logics. So yeah, that's what I want to say mainly. So I want to say business logic drives the transformation in simple words. Okay, yeah. And I would also say this is actually why this is also why data transformation is actually tightly connected to data modeling. Okay, now let's move on to this is with regards to like kind of analytics, right? But now let's maybe also a little bit touch upon machine learning transformation, or also feature engineering. Okay, so let's talk about that. Of course, I'm not going to talk in detail. It's mainly for you to give some kind of idea on what kind of transformations we do, and what do people actually mean when they say something, when they use some word called like feature engineering. I'm pretty sure many of you might have heard this name, but only some of you might be able to understand, and that's totally fine. Of course, we are here to learn and understand and grow. So now, if you are dealing with machine learning, okay, if you are dealing with the machine learning, then transformation normally includes featurization. Okay, so now, don't worry if you don't know what does featurization means. So featurization, in simple words, its main purpose or its main meaning is to, convert raw behavior into the signals a model can learn from. Okay, so in machine learning, what we mainly do is like we'll kind of will kind of have some input data, okay, from where or from which model can learn the rules from, right? So featurization main meaning is to converting that raw behavior into signals that that machine or that model can learn from, okay. So featurization is about converting raw behavior, okay, converting raw behavior into signals that model can learn from, right? Yeah. So now let's see. Let's talk about some example. Okay. Let's keep these definitions aside. They are so boring. So let's talk in examples. Okay. So let's say you have some kind of table for login events. Okay. So what do I mean by login events table? What kind of information can it have? Let's say it can have, let's say for example, user ID column, which indicates that which user has logged in. And then of course it should also have timestamp column, right, to indicate like which user has logged in when, okay. So um, for this, I would say some of the features can be, so if you have to talk in feature senses, then some of the features can be, we can have features like session count, yeah, session count last 24 hours, okay. Or other features can also be like average seconds between logins or average time between logins, right? So let's say if user A has logged in at time A and then he logged out, but then maybe he logged in again and then logged out and logged in again. So like that, they might be logging in and logging out multiple times, right? So in featurization, so one of the signals or one of the one of the feature can be like average seconds or average duration between logins, and other can be session count in last 24 hours, how many sessions, okay. And other can also be like time since last activity, okay. Yeah, so these can be some of the example features. But now, how do we actually get these features, from this data point or from this raw data set? Okay, and we talked that featurization is about converting raw behavior into signals that model can learn from, right? But how do we actually go from here to here? We go from here to there through data transformation, right? and and since like featurization is mostly done by data engineers, no, not data engineers, sorry, data scientists, okay, they might use, I don't know, maybe PySpark or Python actually, or some of the Python libraries, okay, and then do the featurization, right? So if you have to actually look at the example code for that one, it can look something like this. So here we have a window function, okay, maybe let's do with this color. So here we have a window function where we are partitioning by user ID and ordering by timestamp, okay. And then in this case what we are doing is we are calculating previous timestamp, so using the lag function, and then we are adding one more column which is login gap in seconds, okay. And how do we calculate the login gap? We'll take the current login timestamp, and then we'll check the previous timestamp that we calculated using lag, and then login gap will be the difference or the subtraction between the previous timestamp and the current timestamp, okay. So that's how we'll calculate login gap in seconds. So that's can be one of the feature, okay. um, And then if you have to find out like average login gap in seconds, then obviously we have to use something, some function called average, which will, give the average login gap, right? And then if you have to get the session count per each user, then what we have to do is we have to group by user ID, and then we have to do count star. That will give us session count in last 24 hours. So now here in this case, the data represents the behavior, not just raw events. Okay, and that's what ML machine learning models need as well. Now maybe let's enter into the final section. Okay, which is we need to talk about like key considerations. Okay, before designing any kind of transformation logic. Okay, so let's talk about key considerations. Yeah. So before writing any line of like SQL code or Spark code or PySpark code or DBT code or Python code, whatever it can be, so we need to ask ourselves few questions. Okay. So most important question of all is, what is actually the business value that we get by doing this transformation that we are about to do? Okay. We should ask, what is the business value that we'll be getting by doing this transformation? Because transformations costs in terms of compute, right? And not everything is worth transforming. So we need to actually, we need to actually answer to ourselves. Okay. What is the business value that we get by doing the transformation? Otherwise, we should not answer. And then we should of course answer, can the logic be simple? Okay, can the logic be simple? And yeah, because complex transformations can break easily and become hard to maintain, right? So we should answer, can the logic be simple? Okay. And of course also in terms of compute as well, we should understand, can the logic be simple? And we should also of course understand what rules are being encoded. What rules, in the sense, what business rules, what business rules are being encoded. Okay. So what is actually from the business that's actually making us to write this transformation? Okay. So we need to have an understanding of this, and we should also of course try to kind of understand whether we should do it as a batch transform or streaming transform as well. Okay. Yeah. Because yeah, because um, because we should always match a transformation speed to business urgency. Okay. We should not do something just for the fun of it, or just because it's fancy. Okay. We should always try to match transformation speed to the business urgency. So if business needs it urgently, then of course we'll go with streaming, otherwise batch or something like that. Okay, and then one more good sanity check will be with the, we should also understand, will the business outcome change if the data is delayed? Okay, and if the answer is no, batch is fine, and if the answer is yes, then streaming kinds of become necessary. Yeah. So that's actually mainly about the key considerations as well, and touching upon the adding one more point to the last one, which is batch or streaming. Streaming actually helps when latency impacts user experience or product experience or risk, and batch helps when precision or stability matters more. Okay. Yeah, and I'm not saying precision and stability matters won't matter in streaming. They do matter, but yeah, you know what I mean. And so to wrap this up, transformation is not just about SQL or Python or PySpark or DBT or SQL Mesh or anything. Okay, it's yeah, it's actually about like being intentional. It's the intentional step where data becomes meaningful and where data becomes useful business people to take decisions, and it's where raw logs or raw data becomes like facts, and where operational events becomes analytic models, and where business understanding finally meets engineering. And to put it simply, storage collects data and transformation makes it valuable. So in simple words, okay, storage collects the data and transformation makes it valuable. Please keep that in mind always. And if you want me to like follow this with a full live demo of showing all the code snippets where we take raw data set, clean it, standardize it, and apply business logic, and then maybe actually also build machine learning features step by step, then please comment that show the live transformation demo, then I'll do that. And if you are following this entire life cycle videos or entire life cycle series, and one the next video on maybe data serving and semantic layers or the consumption patterns, just comment that next episode, and I will do that. And if you have found this been if you have found this series been super helpful to you, or if you have found this video to help you in some way, then please like the video and share it with your colleagues or friends, and comment what you want to watch next. And yeah. And yeah, thank you so much for watching, and I'll of course come back to you with one more interesting topic. Until then, stay tuned and see you, and bye bye.